Hello students, I hope you are doing well, taking care of yourself and your family. Meanwhile, you must remain engaged in all your academic activities, and that's one reason why I started this lecture series. So, in the continuation of the previous lecture, today I will talk about some misconceptions in reactive power theory. In the previous classes, we have learned how to formulate the objectives based on this theory and how to extract the reference currents. And once we extract the reference currents, then how to track those currents with the help of a power circuit that is called voltage source inverter. And today we will see some conceptual discussion on this theory, that whether when we define the different kinds of the current components based on the power description. If you remember, in the previous classes, we have used the term I alpha P, I alpha Q, I beta P, and I beta Q. Are they matching the conventional notations of the current components, or are they consistent with the standard definitions of the active and reactive components of the current? All right. So today I will start with three-phase, three-wire system, which I have also explained you earlier. Okay. Now for three-phase, three-wire system, as you know, that we can write the ABC components in terms of the alpha beta components. All right. So if I do so, then we can write like this. We have a voltages which in ABC plane like ABA, BB, and BC. These voltages are expressed as ABC voltages, and this is the matrix. I'm sorry, something is not coming proper. And this is the 1 by root 2, if you remember, 1 by root 2, 1 by root 2. This was the 0, 1, minus half, and 0, root 3 by 2, and minus root 3 by 2. This is equal to B0, B alpha, and B beta. Okay. Similarly, we can write for currents. Okay. In currents, you will use the I alpha. So this is I alpha, I beta, I0 and I alpha and I beta put in the same sequence rather than changing the sequence. It will be better for us. So this is I quite 0, then I alpha and I beta. Okay, now this is equal to same matrix. This matrix won't change. The nature remains same. So this is 1 by root 2, 1 by root 2 and 1 by root 2. This is 1 minus half and 0 root 3 by 2 and minus root 3 by 2. This is here I A, I B and I C. Okay, so this is voltage and this is the current. Now since we have three-phase, three-wire system, we have three-phase, three-wire system, and for this particular case we can have, therefore the voltages are balanced and they have a fundamental component. So balance voltages with fundamental frequency. Okay, obviously this signifies, if I have this condition, basically it implies that BA plus BB plus BC is equal to 0. Correct? And since three-phase three-wire system, this implies IA plus IB plus IC is equal to 0. Okay? So these two conditions shows that actually the one variable is dependent on the other two variables. So I can express IC in terms of IAIB and BC in terms of the BA and BB. And hence the degree of freedom is basically 2. Okay, that means, in other words, the zero sequence currents and zero sequence voltage are redundant in this system. So we can reduce these two equations in form of the only alpha and beta components. Okay. Now this implies kind of a B0 is equal to 0, and this implies that I0 is equal to 0. So we can write the current in the only two variables, that is B alpha and B beta will be nothing but this matrix, which is 1 minus half, and this is 0 root 3 by 2 minus root 3 by 2, close this bracket, this into BA, BB and BC. Okay. Similarly, we can write the current here in terms of I alpha and I beta. Okay, so we can write the current here as I alpha and I beta as 1 minus half 0 root 3 by 2 and minus root 3 by 2. IA, IB and IC. Okay, is that clear? Now once I know I, B alpha and I beta, I can further simplify. Since we have taken the balanced voltages, so there is a further chance of reducing this operation into 2 by 2, because as we said that the third component is redundant in terms of the two component, and hence we can express this alpha and beta in 2 by 2 matrix. So what is that? So from this, if you look, okay, if you see from these two expressions, you'll find that these two can be transformed like this, that B alpha is equal to BA, and this have a factor of 2 by 3. I have forgotten to write it 2 by 3 factor. So remember, this factor is 2 by 3 here. So I will just correct this here. Okay. Therefore, you please put it that this is equal to 2 by 3 square root as a transformation. This is also 2 by 3. So 2 by 3 will come here for this particular case. So this is 2 by 3 here. Okay, this into BA minus BB by 2 minus BC by 2. As you know, the sum of three voltages is equal to 0 from this equation, which implies BC is nothing but, or minus B by 2 minus BC by 2 is BA by 2. So this becomes BA by 2. The time functions. So therefore, this is nothing but 2 by 3 square root into BA plus BA by 2. Alright, and this becomes 2 by 3 into 3 by 2 BA, and which is nothing but root 3 by 2 into BA. Okay, therefore we have V alpha is equal to root 3 by 2 root into BA. Similarly, we will find out B beta in terms of the A and B components. Okay, so B beta, if you find out, you can use the second equation, which is this one from here. Okay, so what is B beta? B beta is nothing but 2 by 3 here. This factor will also come 2 by 3 here. In all cases, it will come root 2 by 3 and root 2 by 3. Okay, so therefore B beta is 2 by 3 root into what is here? It is 0 into BA. Okay, so 0 into BA, nothing basically 0, and this is root 3 by 2 is common to both, and this is BB minus BC. Close this bracket, close this. And we replace BC in terms of BA and BB. So they become minus BA minus BB. So this becomes plus BB plus BA plus BB. Okay, and this becomes nothing but BA plus 2BB. So this whole get transformed to BA plus 2BB. This into factor of root 3 by 2, and here we have a 2 by 3. This is 2 by 3 root. So this will go away with this, and finally we have 1 by root 2. This is B beta, which becomes 1 by root 2 into BA and root 2 into BB. Am I correct? So therefore, we can write here B beta equal to BA by root 2 plus root 2 into B. This is second equation, and similarly we can find for currents. These two equations transform this 3 by 3 matrix into 2 by 2 matrix, and hence we can write as this is B alpha here, this is B beta, okay, can be written as root 3 by 2 whole thing. This is 0 here, this is 1 by root 2, and this is root 2. Close this 2 by 2 matrix, and this becomes BA. So now we have expressed in terms of the A and B. As I said in the beginning, since it is a 3-phase 3-wire and it is a fundamental balance voltages, therefore zero sequence is eliminated, and that also signifies that the third phase is redundant and BCS has been eliminated. And finally, we get expression of B alpha and B beta in terms of BA and BB. Okay, now this is important because we have to express the alpha beta components and in terms of A and B, and we have to find out the equivalent components of active and reactive power components in terms of the current. That's why we are transforming these ABC into alpha beta. Fine. Now coming back to the same expression, that is the current components. So based on that, we can also write the I alpha and I beta similar to this, that is 3 by 2 root 0, and this is 1 by root 2, and this is root 2 into IA and IB. Okay, let us call equation number 1 here and call it 2. And these expressions also gives idea that what about B and BB and I and IB in terms of alpha and beta. And this can be done by taking the inverse matrix. Okay, so here in this particular case, we can also express them back in terms of alpha and beta. So if you do it like this, that BA, BB, okay, in terms of the alpha and beta, then it is inverse of this matrix root 3y2 0. This is 1y root 2 and this is root 2 into inverse of this matrix, and this is B alpha and B beta. If you find this matrix, inverse of this matrix, then you will see that 1 by determinant is 1 by root 3 here. Then cofactors transpose of this. Cofactor is root 2 here. Cofactor is minus 1 by root 2. Cofactor is 0 here. This is root 3 by 2. And the transpose of this matrix. This is B alpha and B beta. Transpose this divided by 1 by root 3, each element will get here 2y3 root here. This is 0. This is minus 1 by root 6. And this is 1 by root 2. This is B alpha and this is B beta. This is BA and BB. And similarly, we can express current as well. So we can find here IA and IB in terms of these components. So 2y3 root 0 minus 1 by root 6, 1 by root 2. This into I alpha and I beta. Okay, call it equation 3 and 4. Alright, so we have these two equations. One is here, another is here, third is here, fourth here. These will be used in the further discussion. Now, let us come back to power. Okay, in power, you have to define the power in alpha beta components. So as you know, earlier we have defined the active and reactive powers, instantaneous active and reactive powers in terms of the alpha and beta components. If you recall, these expressions will be like this, that P is equal to P is equal to B alpha into I alpha plus B beta into I beta. And Q is equal to B alpha into I beta minus B beta into I alpha. This comes from the cross product and this comes from the inner dot product. Remember? And this can be expressed in form of a matrix P and Q equal to, this is B alpha and this is B beta here, right? And this is B beta actually, so please correct this. This B beta, and hence we can write this as B alpha B beta, and here we write as minus B beta and B alpha. This is I alpha and I beta. This is same matrix but in a 2 by 2 form. Let us call this question as 5. Okay, and this gives idea that we can express I alpha, the current component, I beta, in terms of the P and Q. So this is B alpha, this is B beta, this is minus B beta, this is B alpha, and inverse of this matrix P and Q. Okay. Now what is meaning of this? The meaning is this, that it is possible to express the powers, this power component, okay, these components in terms of the current components. Now take the inverse of this, you will get again 1 by determinant, which is B alpha square plus B beta square, in brackets the cofactors transpose, get B alpha here, this is plus B beta here, this is minus B beta here, and this is B alpha here, transpose of this matrix, this is P and this is Q, which is equal to, okay, B alpha by B alpha square, B beta square, minus beta will come here, so minus B beta by B alpha square plus B beta square, and this is B beta by B alpha square plus B beta square and B alpha by B alpha square plus B beta square. This into P and Q. Correct? Now this gives idea that if I multiply the row, this row to this column, I will get two components and their addition. Similarly, two components for this, as if there are two components of current. In other words, we can write this equation further like this, that we have a B alpha and by B alpha square plus B beta square into P. This is I alpha, can write, and then plus minus B beta by B alpha square plus B beta square into Q. And if you remember, these two terms also have been explained earlier. This is called I alpha P. Okay, and this is called I alpha Q. So alpha has two components, the active components and the reactive components. This is the total current. And what is I alpha P? Obviously, this is the term for I alpha. and I beta therefore is equal to the whole thing B beta by B alpha square plus B beta square into P plus B alpha y B alpha square plus B beta square into Q. This is also called as I beta P plus I beta Q. Okay, so therefore we are able to express these components in terms of the alpha, and the active components are alpha and active components of the beta. Nevertheless, we have to express back these components in A and B form. So as I said in the beginning that these expressions tell about that I alpha has two components. So we will use this expression actually, that is the, let us say this expression, okay, that is IA. We finally want to express the active and reactive components of alpha and beta in terms of the A and B active and reactive components. So this matrix from equation number 4, which shows that IA, IB equal to, this is 2 by 3, so 2 by 3 root 0 minus 1 by root 6, and this is 1 by root 2. This into I alpha and I beta. Okay, this is what equation number 4 is. Now I will express alpha as alpha P plus I alpha Q. This is I beta P plus I beta Q, and which means that it is the matrix of each term. This is 0, this is minus 1 by root 6, this is 1 by root 2, this is I alpha P, I beta P plus 2 by 3 root 0 minus 1 by root 6, 1 by root 2, again this into I alpha Q, I beta Q. Now what do you expect? This whole term, this is comprised of the active component, and this comprised of the reactive components. Okay, this is the reactive components. This is comprised of the active component. It seems that forms IAP, this is IBP, and this is IAQ, this is BQ. So this resolution tells that how the active components in alpha beta get transformed to this component, and how the reactive component get transformed to this curve. And this is IA, this is IB. Alright, so in this current resolution, current discussion, we would like to find out the IAP, okay, and IBP, IAQ, and IBQ, for a given system parameters. Okay, so in this following discussion, we will try to understand these components. Maybe I will continue to the next lecture, okay, where I will demonstrate that for a three-phase unbalanced system, how these components are computed and they are explained in terms of the system behavior. Okay. So in the next class, I will take the example 5.2 of the chapter 5, which I have sent to by a attachment, a soft copy of PDF copy of that. Please go through this so that I will, when I explain, it will be easy for you to understand in a far better way. Okay. So I will continue in the next class.